let's begin. So I had a dream, and in my dream, I was in a library. But you know how in some dreams you might recognize someone and they don't look like this person, but just because of the environment of the dream, you can tell that it is this person? Well, this is how I knew this was a library. Not that it mattered for most people living in the library, but in the backdrop of their lives were bookshelves. But most people didn't pick a single bookshelves in their lives. They spent their lives in these large octagonal rooms. In these rooms, there were 4 hallways, and each hallway connected to another octagon. Sorry, did I say octagon or hexagon earlier? Well, anyway, octagons. In each room, there were 4 hallways connecting to other rooms, and in between these rooms, there was like restrooms and all the facilities needed for life. And from the center of the room radiates a permanent light. From the ceiling of all these rooms hangs a fruit tree. In the silence of the library, people communicate with signs to each other. Every conceivable meaning is communicated quietly this way. And each sign corresponds to one of 32 words, or 16 numbers. For example, in my dream, people counted with their fingers. But the way they did it was a bit slightly different. So they would count, 0, 1, 2, 3, 4. So if we look at in German, in Inglourious Basterds, there's this pun where it's like you're 3 beers. Well, Americans would say 3 beers. Well, in the library they would say 3 beers. In each octagon there are 4 walls, and each wall holds 4 shelves. On the shelves, instead of Borges' 410 pages books, which are each 40 lines high and 80 characters wide, well, these books are perfectly square, and each line contains 16 letters, 16 lines made of 16 characters each. The pages are made of a material that feels like bark a little bit, and on it grows a moss that you can sort of like mark with a reed and erase like a carpet with your hand. Like you write something on a carpet because the fabrics would like lean on one way. The language uses one of these 2 glyphs, letters. You don't need to learn them, and I won't be teaching you them. I just wanted to show you, some of the attributes of the language. There are also 16 characters, and if you notice, they basically correspond to the 4 fingers. And I showed you before. If you say 3, it looks like this. The alphabet have the properties of some other alphabets that we're familiar with. Like on the left we have Aleph, Bet, Gimel, and on the right you have the language of the dream, and it's like one. Well, there's even names for them, but In, Po, So, Ro, whatever. But unlike the Latin alphabet, in which most of the organization of all the permutation of the Latin alphabet will not unlikely give you something that has meaning, well, in this alphabet, it does. In the Latin alphabet, you might write something, it has no meaning. I mean, this has absolutely no, hopefully, has no meaning to anyone, but every permutation of this alphabet does. So that has some quirks. Well, one of it is that if you change one thing, it throws the meaning of the whole book in a totally different direction. Where with the Latin alphabet, well, it doesn't really matter which way you can sort of like, it still can make up some sentences and words, even if the letters are shuffled. But this language has other quirks. One of it is that, for effect, a sentence might tell you to read the same sentence 5 times. This is the sentence that tells you, go back and read it again. In the library, in the dream of the library, people would call lazy people who would see a word like this, which means infinity, and not infinitely read it, but just move on. They would be like, okay, so this is the word for infinity, I can use it in a sentence. But not everyone has this peculiarity. Some people would just get stuck reading the same the same sentence over and over again, not knowing it would end. So in these infinite recursion and in these books telling stories that might not end, people who pick up books might spend their whole lives. And since you can't be sure if a sentence will end, some people are are certain that it must hold some kind of meaning, so they keep on reading. They are fiendishly difficult or vicious sentences like this one, which is basically the implementation of the tack function, if you've ever seen it, which is brutally recursive. Well, people will pick up these books and get stuck in these sentences that just recurs forever, or, well, seemingly forever. You can imagine that this consumed a lot of readers' times. Here's a fragment of a book which can be read in both directions. I mean, it's hard to see or to understand if you don't know the letters, but if you can sort of have a glance at, the first few letters are the same one that ends at the other one. Well, I mean, people in the library would call these a palindromic book. So the question with the palindromic book is that, well, people wondered if maybe if we read each book from the first page to the last, or to the last to the first, might not we find, actually meaningful books doing this process? Well, people suggested that this would save time. Others realized that, well, they might have come upon the book, not just misreading it, like maybe someone from Japan would have picked it up from the last page and read it backward, but it made people question if maybe they hadn't missed out on an actually meaningful book. This sentence just so happens to print the words tenet in ASCII. That's just a quirk of the. Some people in the library believe that the astronomical number of permutations that we can find in these 65,536 letters books were too few. Others that we didn't have enough pages in the books, and that the alphabets had too few many characters. Some people will be, get on with the times, we need more books, bigger libraries. And I was, in my dream even, I was sort of struggling with this, and I was like, no, we haven't even begun to explore the library. But even in my dream, I had the feeling that other libraries must exist, just by seeing the negative spaces in this. Some believe in the library that we use too many characters, and we might as well just reduce it to 2. Why bother writing what was before if you can just write this? You have two characters to learn. 16 times easier to learn as a language. But others, which had an interesting point, told me something that is interesting. We could do away with some characters, and it would lead us in different ways. In fact, in my dream, wandering the halls of the library for a long time, I found an ancient stairway that led me closer toward the sun. And as I made my way deeper toward the sun, I traced my fingers on the walls, and I noticed that the brickwork changed. And at one point, I realized that the library in which I was living was built on top of much older foundations. And at the end of this stairways and hallways, I found myself at a sort of something that looks like the shape of like in a tower where people would throw arrows from. And at the end of this dark little narrow corridor, I noticed someone was looking at me from the other side. And for some reason, this person evoked in me a sense of loss. But we started talking. And this person convinced me that by just using these 4 characters, we could recreate, or at least retell, every story of every libraries. And I was very dubious, I guess. Oh, I mean, I was incredulous to that at first. But I would like to explain to you how it worked. So from now on, the slides, I will stop using the conlang and all the weird glyphs. We're going to use numbers, because otherwise it's not going to. So I'll use decimal numbers. Prime factoring. It means that you're basically breaking down a number by its indivisible parts. Some people call it the DNA of a number. When you multiply a number by a fraction, what you really are doing is decrementing the value of 1 prime by the denominator, which is the number underneath the fraction, and incrementing that prime number by the nominator? No, the one on top? numerator. When you multiply a number by a fraction, the number underneath, the denominator, removes one prime, and the one on top adds one prime, which is an interesting effect. So, for example, in this case, if we multiply 18 by 2 over 3, basically what we're doing is removing a 3 and adding a 2. And if we multiply by 3 over 2, what we do is remove a 2 and add a 3. So we can think of a number as a sort of a bag, I guess. A bag that contains numerical values, primes. And the books of this library, where you only could use a single operator, which is the multiply operator, you'd find pages covered with these fractions. And a book might read like this. So as an example, it begins with the bag, which is the number 28, which I showed you before. It holds the number 2 and twice the number 3. Now we have a series of fractions, and we'll consider this as our story, multiplying 18 by these fractions in a sequence, starting by the first one. If the modulo of 18 over 2, the denominator, or over 3, if it yields 0, that means that it's a way for us to test if the bag contains a specific item. So, for example, if we start here with 18, we would do like 18 multiplied by 5 over 2. 18 does contain a 2 as one of its prime integer, so we take it off and we put a 5. Then we try again. It doesn't have another one, so we move on to the next one. We remove twice the number 3, and we end up with 5 times 5 times 5, which is kind of interesting because basically what this little sentence does, made up of 2 fractions, is adding 2 items in the bag and putting us the result 3 of adding 1 plus 2 in the 5th register. From this, we can devise a sort of like a computation model that is implementable like this in pseudocode. So that's kind of interesting because most languages, or like single instruction computers that I'm familiar with, or sublec and all these, are much wider systems, even if they claim in their simplicity that they are not. But I mean, even this is too complicated. Like there's a fundamental, primordial way of looking at this that is even more accessible to people, and I think that might have been overlooked. And I would like to show you how that works. So basically, a fraction, it's a bunch of numbers, and the brain doesn't parse this very well. There's a better way of looking at this. So this is the fraction 3 over 2. Basically what we're doing, we're replacing whatever you have in your prime number 2 and putting that same amount of things in your prime number register 3. So basically you're moving one thing from a bag and putting in a different one. Let's say you have this word that would say, like, take out an apple and put down 2 oranges in your bag. Well, you can represent that transformation by a single fraction, and multiplying any number by it will apply this to its prime. And if you name the primes apples, oranges, shapes, triangles, whatever, you're getting exactly this. So the program that we had before, in multiplying 18 by 5, 2, or whatever it is, which is opaque as hell, can be explained by these 2 simple sentences that basically like rewrite rule of an apple for a sum, an orange for a sum, basically evaluating the page of this book. What you get is the result in sum, which is 3. I'm using words, but we might as well just use shapes or sounds or taste or whatever. And but this goes through the whole computation stack. I mean, I've just shown you how to add stuff, but I mean, I might as well just show you how to make logic gates and other things. But for example, this is how you would have. I mean, this could be represented in fractions and stuff, but I mean, as we're human beings, this is much easier. This is a logic gate AND. If you have an item X and an item Y in your bag, and the item AND, because we're going to use, well, you replace these 3, you take off these 3 things, and you put a true in it. And this is basically what computation is. It's a state of transformation of state, and here we're just representing it as fractions or rules or changes. This is how you would get the difference between 2 things. So if you have 3 apples, 2 oranges, well, you remove one of each time, and what you're going to end up is a difference. You can do Fibonacci number. One of the interesting quirks of this system is that it's reversible. I think even in my dream I had a shiver when I was told this. There are sets of rules or pages in a book that have programs that are reversible. That means that by starting by the end state, you can, because of the primitive of the system, which is a fraction can be undone by swapping the denominator and numerator, and you would undo this fraction. Well, because of that quirk, you can read the book backward and find out where you started from, which is an interesting thing. This only holds if the right side or the left side of the fraction is unique, but still kind of interesting. So where does that leave us? Well, in my dream mind, I guess I was reeling. I mean, this is crazy. Like have I just, you know, was told at like a primordial way of doing computation in my dream? Like, what does that mean? Like, this can be explained in 10 seconds. It can be done. It can be played with if you have bricks or marbles or lint or whatever. And I even made a zine. I gave some away yesterday, and it's like 6 pages long, and it basically covers this whole talk. I mean, I'm just like stretching for time right now, but because the idea I want to communicate is so simple. I mean, I'm using that platform to communicate this and made pretty slides, but really in 10 seconds, we tried it, and you can basically teach anyone to, you know, like, it's tally marks, Roman numerals, all these kind of things people are familiar with, but actually you can do computation with that. But yeah, like I was so excited in my dream. I want to see the other libraries. Is there libraries where there are no books? And the person at the end of this hallway that looked like at the hole where people would throw arrows from, well, yeah, there are other libraries that have no books. That people in them burn the books, and I just couldn't believe it. People would actually do this. Like, what's wrong? Like, what's wrong with them? It's inconceivable, and I mean, it's painful enough to think that some people don't even pick up a book from the shelf. What's wrong with them? If it was up to me, I would just force everyone to be reading books all the time. Well, the person stops me. Well, why do you think, you know, the first person ever pick up a book from the shelf? I don't know. Like, fiction. They were bored. Fiction. They want to learn some history or understand the universe. Well, it was so they could better kill someone at a distance. Then I wake up, and dreams are weird. And I noticed I fell asleep in front of my terminal, waiting for the ARM architecture manual to open. and it's still loading. Thank you.